Mars, the enigmatic neighbor to our blue planet, has captivated human curiosity for centuries. Today, we embark on a journey across time and space, a quest to unravel the greatest mystery of all. Has life ever existed on the red planet? And could it endure there even now? The story of Mars reaches deep into the roots of cosmic history, uniting breakthroughs, challenges, and hopes into one relentless pursuit. Join us as we dive into the most shocking evidence, confront the planet's harshest realities, and witness the extraordinary efforts humankind is making to answer the cosmic question: are we truly alone? Billions of years ago, as Earth was just beginning to cradle the earliest forms of life, Mars was a world remarkably different from the barren desert we recognize today. Imagine a planet painted with the colors of water, vast oceans shimmering under a thick, warm atmosphere, rivers winding through ancient valleys, and lakes cradled in deep basins. The air was denser, the climate milder, and the planet's magnetic field shielded its surface from the ravages of cosmic radiation. Evidence suggests that around 4.48 billion years ago, Mars may have been habitable, potentially even before the earliest known life on Earth appeared. The Martian landscape still bears silent witness to this glorious past. Rocks etched with tiny vugs, remnants of dissolved salt crystals, hint at the flow of ancient briny water. Spherical blueberries of hematite dot the surface, formed only in the presence of liquid water. Ripples in sedimentary rocks, carved by persistent currents, preserve the memory of great bodies of water. From space, satellite images reveal winding canyons and riverbeds that mirror those on Earth, while meteorites from Mars carry traces of hydrated carbonates and sulfates, proving that water once bathed the red planet. These clues are not mere speculation. They are the fingerprints of a planet that may once have been a cradle for life. Yet, this idyllic era was not to last. Around 4 billion years ago, Mars suffered a planetary catastrophe. The planet lost its global magnetic field, the invisible shield that guarded its atmosphere against the relentless wind from the sun. Without protection, solar particles stripped away much of the Martian air in a matter of hundreds of millions of years. The once thick atmosphere dwindled to a tenuous veil, less than 1% the pressure of Earth's. Temperatures plummeted, averaging 58 degrees Celsius, with wild swings between day and night. The surface became a desolate wasteland, bombarded by deadly ultraviolet rays and cosmic radiation at levels 40 to 50 times higher than those on Earth. Today, Mars appears inhospitable, its thin atmosphere of carbon dioxide incapable of supporting stable liquid water. The planet's surface is frozen, dusty, and bathed in lethal radiation. It seems impossible for life to survive under these conditions. But is hope truly lost? If life ever took root on Mars, could it have found refuge hidden beneath the harsh surface, waiting for discovery? The search for Martian life took a dramatic leap in 1976 when NASA's Viking landers performed a groundbreaking experiment known as the Labeled Release (LR) test. The aim to detect signs of microbial metabolism in Martian soil. The result was electrifying. Both Viking landers, thousands of miles apart, produced positive, repeatable reactions, mirroring biological activity seen on Earth. Gas was released from the soil after a nutrient solution was added, hinting at the possibility of living organisms. Yet excitement soon gave way to skepticism. Another experiment failed to detect organic molecules, long considered essential hallmarks of life. Many scientists declared the results were a fluke, a product of unusual chemistry rather than biology. But the debate was never truly settled. In recent years, as new missions have discovered water, organics, and mysterious methane on Mars, Viking's data is being re-examined, notably the fact that the LR test's active agent was destroyed by mild heating and storage, consistent with earthly microbes, but harder to explain by chemistry alone, has kept the door open to possibility. Viking's results remain unique, the only direct evidence from pristine Martian samples, uncontaminated by potential earthly microbes. The search did not end there. NASA's Curiosity rover, exploring the ancient lakebed of Gale Crater, delivered another breakthrough. By drilling into Martian rocks, Curiosity uncovered the largest organic molecules ever found on Mars: decane, undecane, and dodecane. These are fragments of fatty acids, the building blocks of cell membranes on Earth. Their presence suggests Martian chemistry has ventured into the complexity needed for life. Even more tantalizing, such molecules could be preserved for eons beneath the surface, protected from harsh radiation and chemical erosion. And then there is methane, the gas that fuels yet another mystery. Orbiters and rovers have repeatedly detected methane in the Martian atmosphere. On Earth, methane is mostly produced by living organisms. Its appearance and rapid disappearance on Mars remains unexplained. Is it a sign of hidden geological activity, or could it be the breath of subsurface microbes releasing gas into the thin air before being swiftly destroyed by sunlight? Some scientists speculate about a hidden ecosystem where methane-producing and methane-consuming microbes form a delicate cycle, tucked away below the surface. To understand what is possible on Mars, scientists turn to Earth's most extreme environments. In the Atacama Desert, bacteria survive by harvesting the faintest traces of moisture from the air. In Antarctica's blood falls, microbes thrive by metabolizing iron and sulfate in total darkness. Deep underground, bacteria live off chemical energy, isolated from the surface for millions of years. Some, like Carnobacterium, endure in permafrost, surviving pressures and temperatures akin to those on Mars. These resilient organisms prove life can adapt to the harshest, driest, coldest, and most irradiated habitats imaginable. If life ever existed on Mars, it may have evolved similar survival strategies, burrowing deep underground where water lingers and radiation fades. The hunt for Martian life is entering a decisive phase. NASA's Perseverance rover is collecting precious samples of rock and soil, preparing for an ambitious mission to return them to Earth for detailed analysis. The European Space Agency's upcoming ExoMars rover, equipped with a powerful drill, will probe deep below the surface, seeking well-preserved samples untouched by the ravages of time and radiation. These missions are humanity's best chance to answer the ancient question, does life exist beyond Earth? Though conclusive proof remains elusive, each new discovery brings us closer to the truth. The search for life on Mars is not just a scientific endeavor, it is a profound exploration of our place in the cosmos. Finding even the smallest microbe would transform our understanding of biology, the origins of life, and the potential for life elsewhere in the universe. The question remains, echoing across the gulf between worlds, are we alone? Mars still guards its secrets beneath a shroud of red dust. But humanity will not stop searching. Hope grows with every mission, every sample, every clue. The answer may be waiting, hidden just below the surface of the red planet, ready to change the story of life forever.